In lesson 6.1, we are going to be talking about differential equations. A differential equation in x and y, it's just any equation that involves x, y, and the derivatives of y. So we have an example right here, 2x times the derivative of y minus 3y equals 0. Okay. For the problems that we're going to be doing, we are only going to have differential equations in x and y. Of course, as you get into higher levels of calculus, more variables is definitely a possibility, but ours are going to be pretty limited. So in order for y to be a solution, that means if you plug in y and the derivative of y, it works, okay? So we'll do some examples of those. Now, sometimes differential equations have singular solutions, and sometimes they have general solutions. If it's a general solution, you'll see it has a plus c in it somehow. And if it's a particular solution, that's when we've solved for that c. And one other vocabulary term is the order. The order of a differential equation is the highest order derivative. So if it has a second derivative in it, then it's order 2. Or if it has a third derivative, it's order 3. Whatever order it is, that's how many constants there will be. So C1, C2, and that type of thing. So let's take a look at a couple examples. We have this differential equation right here. The second derivative of y minus y equals 0. So this has order 2 because it has a second derivative in it. And what we have is several different equations for several different functions, and we want to see if they work. So what we're going to do is we are going to plug each one of them into this and see if it works. So we have y equals sine x. So we're going to find the first derivative, which is cosine x. And then we're going to find the second derivative, which is negative sine x. Okay, and now I'm going to plug both of those into this. So I take the second derivative, negative sine x, minus y, which is sine x, and we want to know, does that equal 0? Which we can clearly see that it does not, so this was not a solution. Okay, so this function is not a solution to this differential equation. Let's try the next one. We have y equals 4e to the negative x. The first derivative is going to be 4e to the negative x, and then we've got a chain rule, so it's going to be negative 4 e to the negative x. Second derivative, again, it's going to be negative 4 e to the negative x, but then you have a chain rule, so it becomes positive. And so now we're going to plug that in. So first, the second derivative, so 4 e to the negative x minus y. So y is 4 e to the negative x, and we want to know, does that equal 0? Which it does. So this is a solution. Okay, this function is a solution to this differential equation. All right, let's try the next one. We have y equals c e to the x. The first derivative is c e to the x. And the second derivative is also c e to the x. And now we're going to plug it into this thing. We'll take the second derivative minus y, which is c e to the x. We want to know, does that equal 0? And it does, so this is another solution. Okay, so this particular differential equation has multiple solutions, and you can see that b and c are both solutions to it. Now, the general solution of a first-order differential equation, it's a family of curves. We call them solution curves. So for example, this function here, y equals c over x, that's a solution to this differential equation. So these are all solutions, and depending on what we plug in for c, we'll have a different curve. And so I want to show you that on Desmos over here. So first, I think, let's see, oh, here we go. If you plug in 1 for c, that's what you get. Or if you plug in 2 for c, so 2 over x, or 3 over x, or 4 over x, or 5 over x. And you could keep doing that. I also plugged in negative values. So here's negative 1, negative 2 over x, negative 3, negative 4, and negative 5. And of course, you could keep doing this. But this on Desmos shows you the family of curves that are all solutions to that differential equation. Now, if we want to find the particular solution, we need to have some sort of initial conditions that will enable us to solve for C. So if our problem, has given us a solution of this, but we want to know exactly which curve it is, we would need to have some sort of initial conditions. So we'll see an example of that on the next video.